All right, this is going to be a very quick overview of the notes that I did in class last time. The audio didn't come out, so I'm going to run through these real fast. First question in class was to try and do one of the problems I had sent everyone home with. It was x to the fourth minus 25x squared. First thing I do is identify the degree as being an even number. That's the 4 here. And then leading coefficient in front of it is a 1, therefore the left and right sides go up. Now we find the x-intercepts. So we take the function, set it to 0, we factor a GCF out, x squared, then what remains inside the parentheses here is a difference of squares. Now I set each of these equal to 0. I get 3 solutions, 0, -5, and 5. Now to determine if we cross or bounce at those x-intercepts, we look at the powers on each of the factors. So we have a 2 here. Even number here means that we bounce. A 1 is odd, that means we cross. A 1 here is odd, we cross. So when I drew it, what I'll do here is I'll draw it again just so we see it. Put the x-intercepts, 0, 5, -5, and then we know the left side goes up, right side goes up, and then we know that we cross through at -5, we bounce off at 0, then we come down, then we go back up and cross through at 5. So that was pretty much it for that. All right, next thing was trying to figure out how to sketch something like this. So gave everyone this polynomial function. The degree is 4 again. That means it's even degree. Leading coefficient is a 1, therefore the left and right sides go up again. Now we set this thing equal to 0 to get the x-intercepts. We factor out a GCF of x. Then we look at what's here in yellow. We try and factor it. We try grouping, so we slash it in half, factor the first 2 terms, pull out an x squared. We realize over here we can't do anything to get an x minus 8 in here. Nothing works. So this fails. So then someone asked some other stuff. Don't worry about this. Then what I did is I said, take a look at these 3 factors right here. Just forget this problem up here for a second. Just look at these 3. Multiply these 3 out. So the first thing that I did is in the red. I did a FOIL here. X times x is x squared. X times -7, -7x. Then you have -4x, so you put those together, you get -11x. -4 times -7 is 28. Take that whole thing in red and then multiply it by that first factor. X goes through, hits everything. The 3 goes through, hits everything. You get all these terms here. You collect like terms and you get this. Then I pointed out to the class that, look, this right here is exactly what we were trying to factor up here. Basically saying that just because grouping doesn't work doesn't mean it doesn't factor. By doing this, we actually see that this does factor to be these 3 terms, or these 3 factors. The question is, how in the world do we know that? So how are we going to do this? So I introduce a new, we're going to try and develop a new technique for factoring. So we start out with this idea of division. I tell everyone in the class, hey, let's just take x squared plus x minus 6. Let's divide it by x plus 3, see what we get. We factor out the numerator, AC method on the numerator. We notice that these x plus 3's cancel, so the answer is x minus 2. This basically tells us that if we take x plus 3, that's what we divided by, we multiply it by x minus 2, which is our answer, we should get back what was up here in the numerator. Essentially, this blue here can be factored into these 2 pieces, which we would have known if I would have just given you this blue piece and said factor it. Factor this, you get this. So now I show them synthetic division. So the way synthetic division works is you take the numbers that are the coefficients of what you're trying to divide, which would be 1, 1, -6. And you have to make sure that this thing up here is in descending order. 1, 1, -6. Then on the outside division box, you take the opposite of what you see here, +3, you put a -3 out here. Now for synthetic division, you bring this 1 down. It's a 1. Then you multiply -3 times 1, that gives you -3. You add down again, you get -2. Multiply through again, you get 6 here. Add down, you get 0. And if you get a 0, okay, that's why I put this over here, you must have a 0 here. If it's a 0, then these 2 numbers here give you the answer. So you put a 1 and then you put a -2, and then what you do is you say, next to the 1, there is an x. And this x comes from up here at the thing we're trying to divide, 1 power lower than what you started with. So we started with x squared. That means we'll have an x. Now, as you move to the right here, the powers come down. So I have a 1x, then power comes down. If that means there's no x's left, so we just have a constant. So this x minus 2 matches up with the answer we got here. But we have this new way of doing it. All right. I believe that's it for that. Yeah. Next page. Okay, now I give everyone this new problem. Here's the new problem right here. Let's try and divide this. And I point out that you could just factor in the numerator and then cancel, and so our answer should be x minus 2. But let's go ahead and use this new little synthetic division technique. We notice that we have a 1 in front of our x squared, so that's this 1. We do not have an x term in here, so we have to put a 0. Then we have the minus 4. The minus 4 here, that's right here. Now on the outside division box, we take the opposite of plus 2, so we put minus 2. And then we play our little game here. 1 comes down. Here's our 1. Negative 2 times 1 gives us the negative 2. Add down, we get negative 2. And then multiply negative 2 and negative 2, get positive 4. Add down, we get 0. So again, because we have 0, we know that these two numbers will help us get our answer. Again, the 1 is in front of an x because the power is 1 less than what we see up here. And then reduce the power, we won't have any x's, then minus 2. And again, that answer matches up with this. All right, moving along. Now we go to this problem here that we started with earlier that we were trying to factor. And I give you this right here. So don't worry about where this came from yet. I'll get into that. But let's just show that this thing will divide into it. So we take the numbers. Let's see, there's a 1 in front of the x cubed. That's here. We take the negative 8 in front of x squared. That's here. The negative 5 in front of x. And then the 84 right here. On the outside, we do the opposite of negative 4, which is 4. Okay, go straight down. Here's 1. 4 times 1 gives us 4. Add straight down, negative 4. 4 times negative 4 is negative 16. Add straight down, we get negative 21. 4 times negative 21 gives us negative 84. Add down, get 0. So what we know is that the three numbers we got here represent our answer. So the 1 that comes down here is going to be in front of an x squared this time because squared is 1 less than the cube that we started with. And then the negative 4 is in front of an x, so the powers are coming down as we move to the right. And then we'll have no x's right here on the 21. So what we know then is that this that I just boxed times this gives us this. So we've essentially found a way of trying to factor that. I believe I'm going to pick up on that on the next. Yeah. Okay. So let me now. The big question in class was on this problem. Everything worked out. We were able to get an answer here, but how do we know to actually come in here and divide by x minus 4? So where does this come from? Where do we get that 4 from? And know that it's going to possibly work. So I told the class we don't have a way to tell us exactly where that 4 comes from, but we have a way of getting a list of numbers that could possibly work. So here's the way it works. This is a brand new problem. We're going to try and factor this. We should already know that factors to be this using like an AC method. But let's just do it another way. So take the number 18 in the back. That's the constant by itself. And think of all the different factors of negative 18. That's all the numbers that divide into negative 18 without a remainder. So 1 goes into 18, negative 1 goes into 18. 2 goes into 18, negative 2 goes into 18. 3 goes into 18, negative 3 goes into 18. Then again, 6, 9, and 18 itself. So what we have here is a list of 12 numbers that could possibly work when we use our synthetic division. So I start with positive 1, and I use that positive 1 here. And then I put down my coefficients 1, negative 3, negative 18. That comes from the original problem. And I try it. 1 comes down, it's 1. 1 times 1 is 1. I add down, I get negative 2. Negative 2 times 1 is negative 2. I add down, I do not get a 0. So this does not work. So I move on to the next number in my list. Negative 1 is the next number in my list. 1 comes down. 1 comes down, and then I'm recording. 1 comes down, multiply by -1, you get -1, add down -4, multiply -1 times -4, get 4, add down, get -14. No, that's not a 0, this doesn't work. So then we move on to the next number in our list, which is 2. 2, if you look at it here, it won't work. And then we do -2, it doesn't work. So this is getting somewhat exhausting, but it's going to happen here. Let's see, 3 doesn't work, but -3 does. So when we put -3 in here, we finally get a 0. So what we do here, I'm going to erase this because I want you to see how this happens. When -3 works, I now take this and say, okay, this 1 gives me a 1x, then the -6. You put that in parentheses, and then you use the -3 to come down here. You take the opposite of -3, which is +3, and you'll always take the opposite of the number that's out there. This is the factorization of that quadratic, as we could come back here and check right up here. That's what we said it should be, and that's what we're getting using this new technique. Now, of course, you would never use this on a quadratic if you know the AC method and you can do it quickly, but this now gives us a technique to factor pretty much anything. So now we go back to the original problem. Well, when I say that, I mean I'm going back to, let's see, it was this problem we were trying to sketch earlier. We got to this problem, we couldn't figure it out. So now we should have a way. Let's see. Let me get back to it here. Here we go. So we want to try and factor this. So we look at 84 in the back. We write down all the factors of 84. Here they are. All of these and all of these. Those are all the numbers that divide into 84 evenly, positive and negatives. And then we go through and we start checking them. And always start at the smallest number. Do 1, -1, then 2, -2, 3, -3. And you want to get it, do it until you get to a 0 remainder. That means a 0 down here. You want that to be 0. So in class I showed that 1 doesn't work, and I didn't show any more, but -1 won't work, 2 won't work, -2 won't work, 3 won't work. So none of those will work when you try them in the synthetic division. However, when you get to -3, here's the work for -3. So -3 out here, 1 comes down. I'll let you kind of look through this, but you get a remainder of 0. So what that tells us, the 1 here tells us we have a 1x squared minus 11x plus 28. And then taking the opposite of what's here, we get x plus 3. So what we know is that the original problem factors to be this line. But then this right here is a quadratic that I would expect everyone can handle with the AC method. That factors to be these two. So now we have the factorization. And we did it using this synthetic division type technique. All right, so putting it all back together, we go back to the original problem and start from the beginning again. Here's the function. We find degree, leading coefficient. It goes up on the left, up on the right. We factor that at GCF. Don't forget about the GCF we pulled out. Then we take that yellow there, we break it down, and we know that that's, I said in the class, that's lots of fun doing that, but it's a lot of work. But we get it. We set every factor to 0. So set x to 0, we get 0. Here, -3, 7, 4. Every single one of these factors has an odd power on it. And because of that, we will cross, I just put a C here, cross, cross, cross at every one of these. So when I go to draw it, let me get this out of here. I put all my X-intercepts there. I know on the left it goes up, the right it goes up, and I must cross through every one of these. So I cross through at -3. I got to come back up and cross through at 0. Got to come back down and cross through at 4, and then I've got to cross through at 7. And that's my picture. So that's pretty much it. Then I gave a homework assignment. So the homework assignment is to sketch this. That's got to be ready to be turned in on, when do we meet again? Tuesday. And then if you want, on separate page, this bonus problem, try and sketch this one. And that's pretty much it. That's what we did.